Hello sir, I'm Panchad M. Sir of System Mechanical Department, roll number MEB19072. In this video, I would like to demonstrate on modeling and finite element analysis of crane hook. I'm using Solidworks software for modeling, uh, and I have downloaded a dimensions for drawing for dimensions. Let's make use of this and let's go to drawing modeling. Take a front plane and take sketches, and I would like to start from this circle, like this curve, radius 232, and let's draw circle radius 232. Take dimensions. It's a diameter, so we'll take for 464. uh, I will display as diameter and I will display as radius 232. And now I would like to take this curve, which is of radius 200, and which is eccentric to this curve to 32 millimeters, and I will make tangent to this for this coincidence. I will make that. I have made this circle, and which is to this eccentric to 32 millimeters. I have made tangent. Mm, uh, and then it is undefined. We will make it defined by making it vertical both points. Then now it is defined. Now let's trim the part which we do not want. Take two lines. As we wish. Uh, Now we take trim entities. Uh, Here we don't want this upper part, higher part. Remove it, and this part. Here we don't want lower, middle part, and this part. Now remove this one also. Now we have this curve. Now let's go to this 106 radius part. For that, we will take this center line, which is uh, 28 millimeters eccentric to this middle part. Now take a center line, uh, and then I will make a part like this. uh, I will symmetric these relations. Take center line. It should be vertical 90 degrees. We can see here it is 90 degrees, and it is eccentric to almost, wait, uh, sorry, it is eccentric 28 millimeters. 8 millimeters, and I will take a small part with small portion of which I will take this symmetry relation, symmetric. I have make that length, this diameter 106 millimeters, and also I have made this height from this to center line 585 millimeters. As we can see here, 585 millimeters, and this is underdefined. For making it defined, totally defined, I think here it is. We have to make is relationship or horizontal. Uh, Now it is totally defined. Uh, this part is totally defined. Now we have to take this part. As we can see here, there is a straight line and there is a curve. We can't make fillet with this because there is a straight line here. So I will make a straight line here, and I will take a radius, like I will take straight line. And now I will take a circle. Now I will make it this tangent to each other, tangent and tangent. This radius is 90 R90. I will take that part. This I took this R90. Now let's trim this part. Make a relation to this tangent so that it will be defined. Yeah, then let's trim this part. Trim entities. Yeah. Now this also. Let's trim this. Okay. We got this curve. Now let's see the diagram. Now it is 325 millimeters from here to this origin part. Let's make this from this point to this origin part. It's 325 mm. 325. Now everything looks good. Now let's go to this inside part. This part. The radius is 80 millimeters, so we have to take diameter 160, and it is 28 millimeters eccentric to this origin. uh, let's take that part. Circle 28 millimeters. This central line also 28 millimeters eccentric, so we can take on this line. Okay, radius 160. Okay, radius 80, radius, diameter 160, and we take this as diameter and display which as radius. And let's take this horizontal, this relation horizontal. Okay, sorry. Make this relation horizontal. Now it's look good. Now here there is a tangent line and arc of radius 240. Let's make this part. Uh, let's extend this. Take a tangent line. And the arc of radius 240. Radius 240. Take a three point arc. Okay. I'll give dimensions to this 240. Now this one has a tangent relationship you have to give. Now you got this arc. Now let's move on to this. This height is 290 millimeters. We will look at after that. Look at this after that. Now let's go to this part. This one. Now it is a arc of radius 335 millimeters. Let's take that arc. And before going to that, it is a 100 millimeter eccentric to this center line. So let's make a center line which is 100 meters above, 100 millimeters above. Okay, take a center line and take a smart dimensions which is 100 millimeters above. According to sensor, sorry, let's take a center line, make it horizontal, which is 100 millimeters above. Now I will make a curve of 335 millimeters and I will show. I can't show everything because it may exceed 30 minutes, so I will pass it and show it. I have made an arc of radius 335 millimeters and I made a tangent to it. Now let's take to this part, which is spherical diameter of 56 millimeters. Okay, let's take a circle which is tangent to 100 millimeters center line. Mm, Make tangent to this line. Now this diameter is 56 millimeters. 56. Make tangent to this line. This. And let's trim this part. Okay, then let's make this curve. There is a radius of fillet of radius 335 millimeters. Let's take a vertical line. Make it vertical. Make it vertical and let's coincide these points. Now there is a fillet of radius 335 millimeters. Let's make that. Now let's make a fillet of 335 millimeters. Mm, Take a fillet, 335 millimeters. Fillet entities for fillet. Let it be this one. This one. Mm, Make it. Now let's make it fully defined. Control. Let's horizontal. Take relationship horizontally. Now it's fully defined. This part is not fully defined. Let's make that all fully defined. Actually, here it's not mentioned that it's horizontal to this. So and here they didn't mention any length of this line. So let's remove that horizontal relationship. Uh, it's not defined yet. So let's see any other what we want. Here, uh, this one is well defined. This one is defined. This one is defined. So and this one this length we haven't defined 125 millimeters and also this height from this point to origin it's 290 millimeters, so let's make that point. I will pause the video and I will do that. I have made this trim and I have dimensioned this length to this distance 125 millimeters and this one from this to this point 290 millimeters. I have trimmed this part also. Now let's move on to this part, section A and section BB. Uh, so now make it as a sketch. Uh, okay, then let's make this 106 line extrude. I will take a plane. We have various methods to do this part to extrude. I will take a plane here and I will make a circle and extrude from this vertex to up to this vertex. I will show by pausing this video. This diameter of 106. Now take this extrude from this vertex to this vertex. Extrude boss and base. So from vertex in reverse direction, take this vertex, take reverse direction to vertex up to this vertex and take this extrude. We got this extrude. Now let's do for this section A and section B. Section B will come in this frame and section A will come from this plane, so that for the use of this is we can take a boundary boss base, and so it will fill the this moment, this total body. So let's do that section A and B. Now for section A and B, A take this top line, uh, sketch this one. We'll take another, like we'll take a center line. We'll take a center line. Now I will this relay take the relation of peers, uh, and from for this curve also take relation peers. Now I will draw this section area with these dimensions. Uh, let's go to this normal view. Uh, I will draw two lines here and one line here and make it a mirror entity. Uh, this line make it a mirror entity. Sorry, and select this one, both mirror entities we got. And now I will make arcs with those dimensions and I will design that one. I have made this section A, this one, and let's see. It will be like this. Uh, Now let's make this section BB, uh, this one, uh, in this part. It will come in this part. I will take it. Now I will select a plane, right plane. Now I will make it uh, coincident with this point. Sorry. And make this coincident with this color. Now let's make a sketch of BB here in that plane. This sketch, I will make it. I hammered this sketch BB. I made this fillets, this diagram and all with these dimensions, radius 28 millimeters, 150 millimeters, and fillet of radius 28 millimeters. Now let's take this spherical part. Uh, you can see this as a sketch. This for this one, I will take a front plane, and I will trim this one, and after that I will make a line here to here, and I will make soft lines. This one, this swept boss and base. I will show it later. I made this one like this. Now I will like to trim this part, and I would like to make this as a revolved base uh, axis. Now I will revolve this base. Take the revolve base. 360 degrees on the result. Now you can see this as a solid part. Now let's reunite these all parts by using boundary boss or base. Let's create guide curve. Select these parts. Sorry. Convert entities. Convert entities. I have applied a boundary base on boss condition to this. Uh, I got the structure. Now I would like to take this upper part, this extruder and base and total. This will be done by making the extrude boss. Here there is a fillet. Here there is a another fillet. I will totally complete this one, and then we will go to analysis process. Uh, Here I will take a sketch. Uh, I will draw a circle and extrude it, and there I will apply a fillet to it. I have completed the upper part. From this, I have completed this modeling. Now I will analyze finite element analysis. I will do the finite element analysis. Now we will do finite element analysis in Ansys Workbench. Uh, Start static structural. Uh, I have imported the file as I have saved the file as a step file, and I will import the file from Solidworks. Import geometry. I have named it as crank hook, crane hook. It's got imported. I will edit the geometry for some force. I will generate that SolidWorks model. Force will be applied in this type and in this plane, and here uh, it is easy to apply force here, and for here it will be difficult, so I will make a plane so that it will be easy for us to generate a force. I will take generate plane. I will generate a extrude and a rectangle, and I will apply force here. I have made a sketch. I will extrude it. It extruded upwards. I will make it reverse. We will extrude through this total surface. So extended. make it a through wall. I will generate it. It got extruded through the uh, now we will go for meshing. Now this geometry, it became three parts, like it's like three parts. I will take a mesh. I will go to method, apply it to three parts, these three parts, three bodies. I will take a method tetrahedron. I will update it. It may take time. Oh, it got. We here we can see the mesh for three different parts. Now we will make a sizing to this. Sizing. I will apply to these three parts, three ones. Element size, its default. We will change the element size. I took mesh size as a 1.5 e power 0.02. I got this elemental size. Now we will apply forces for and also boundary conditions for now I will take the fixed plane, fixed support. In fixed support, there will be 6 degrees of freedom for this. Now I will apply force to this. Apply force to this. Let's apply force. I will select this one. Apply it. We have applied force. I will apply it by components defined by and I will make the force on the minus y component 1000. Now I will solve. Now let's see the solution. We want deformation, directional deformation. In directional deformation, we will see in y-axis, uh, y-axis. Now we will evaluate the results. Uh, it may take time. Select directional deformation. We got this. Uh, let's see some animation. I have selected a equivalent elastic strain and that is a one missile event, one missile strains. Uh, here we can see this. You can see the animation for the. Here we can see the maximum and minimum strength. We can see equivalent stress here, maximum and minimum equivalent stress here. Here we can see total number of entities 127 and result summary. Uh, Thank you so much, sir, for this opportunity. We have learned so much from this course. Thank you, sir.